I'm Bill Snodgrass, and in this World Around Us video, we're going to do a virtual lab. We're going to use the physical properties of a substance to try to determine what that substance is. The video is going to be set up like we've done other lab videos. We'll have a discussion of the procedures so that if you're doing it in class, you'll be able to, to do the activity. If you are doing it as a virtual lab, then the second part of the video will collect the results and report those to you. And if you're just watching the video, the conclusions will follow. So we have an unknown sample of some sort of, it looks like metal. We're assuming it's metal based on physical observation. And what we need to do is our strategy is we'll find the density and then look up things that match that density and then compare the physical traits of what we find on a density chart to the other things we observe about the sample. So in order to do this, we need to find the volume and the mass, and then we'll compare it. We'll do the other tests after that to see how it goes. Because it's not a square or a cylinder or something that we can calculate using geometry, we need to find a way of calculating the volume of this sample. So one way of doing that is a displacement test where we put the object into a liquid and then measure the rise of the liquid. That displacement is then the volume of the object that was submerged. Before we do that, we need to find out, is it going to react with water or is it going to dissolve in water? So in order to do that, we're going to start with a solubility reactivity test. So we're going to take a small piece of the sample and put it into a test tube. We'll put two small pieces in. And we're going to put just a little bit of distilled water in to see if there's any evidence of a reaction. So there's no bubbles forming. There's no precipitate forming. None of the evidences of a reaction. So we'll give it a little more water in and see. Nothing seems to be happening. So the next thing we want to determine is it going to dissolve? So I'm going to put a little bit more water in. And in order to agitate it without spilling it, I'm going to put a stopper on it. I'm going to let it sit for a moment. And then again observing, I see no evidence of it dissolving or reacting. So I'll agitate it gently. And there seems to be no evidence that it is dissolving. So we're going to begin by saying that it is not soluble in water and it does not readily react with water. So those are the results of our first two tests, which we need to know those results before we carry on with the other test, that is the displacement test. So in order to find the density, we need to find the mass and divide it by the volume. So we're going to use a scale, and this scale reads to the 1/100th. The mass will be in the results section. So having recorded the mass of the sample, we're now ready to move on and find the volume of the sample. And we're going to do that with the displacement method. And so we record the initial volume of the liquid. And then we're going to put the sample in and record the final volume. Then the volume of the sample will be the difference between the final volume in the graduated cylinder and the initial volume. And it looks like this. We're going to take the sample and we're going to carefully put it into the graduated cylinder. We're not going to drop it from up high because it's glass and we don't want to break it. And now that's going to raise the level of the liquid, and we're going to take that final measure and subtract it from the initial measure, and that's going to give us the volume of the sample. So that's the procedure. So let's review real quickly. First we find out, does it react with or dissolve in water? It does not. If it does not, we can proceed with the displacement test using the scale to find the mass, using the liquid to find the volume. So those are the first three tests demonstrated. Another test that's very simple to do is to test it for magnetivity. And we do that simply by approaching it with a magnet and determining. The magnet I have is round, and I have it stuck to a piece of metal so that it doesn't roll off the desk. So as you can see, if the sample is magnetic, it very aggressively attracts. So the last test we're going to do is to approach the sample with the magnet and see what happens. All right, so those are the 4 tests that we're going to run on the sample. One is reactivity to water, solubility in water, number 2, number 3, the density, and number 4, magnetivity. So now we're going to move on to the results section of the video, where we're going to actually look at the results and discuss them. So with regards to the results, then solubility with water, we did not notice any solubility, any dissolving, so that we're going to say is not readily soluble in water. And with regards to reactivity with water, also not readily reactive. We did not notice any reactivity in the course of the experiment. With regards to the mass, we put it on the scale, and here are the results from that. 31.36 grams is the mass that we came up with. So that's going to be your mass for the sample. With regards to displacement, our initial volume was 30 milliliters. Exactly. We set it up that way on purpose. We made it 30 milliliters to start with so that it would be easier to determine the volume. Now, after we put the sample in, we had to find the final volume, and it was a little between 34 and 35. It was a little bit between 34 and 35, and extrapolating the lines on the graduated cylinder, I'm going to call this sample having a volume of 4.33 milliliters, which is cubic centimeters cubed. So we're going to end up with a volume of 4.33. So we have a mass of 31.36 and a volume of 4.33. In the conclusion, we will calculate that and discuss what that means. The next result would be the magnetism test. And as we said, as we approach the sample with a magnet, will it or will it not, do that attraction thing that is so readily, because it's a very strong magnet. So it does not attract magnetically. So we would have to say that the characteristic of magnetivity is it is not magnetic. It is not magnetic. So those are the 4 tests. We're going to take those tests and do our best to come up with an answer as to what this could be. So the next thing we're going to do, in our results, we're going to take our results and go to a table, and I'm going to Google density of metals, known density of metals, and we'll come up and see what we come up with. And we see here's a chart, and we can go through the chart until we find something that has the number that we came up with. And we'll look at that in the conclusion section. Then we're going to compare that, whatever that metal that comes up, we're going to say, well, is that metal soluble in water? Just Google, is whatever you think it is soluble in water, yes or no? Is that metal reactive with water, yes or no? Ours was not. In this case, ours was not. So if you find something that matches the density but is reactive with water, that thing cannot be the thing that reacted with water, because our sample did not react with water. Same thing with magnetivity. If you find, if you were to find that, it was stainless steel, if your density, stainless steel is magnetic, whatever this is. This was not. So the results of the magnetivity test would rule out whatever this is made out of. All right, let's move on to the conclusion. All right, our conclusions. We said, you know, that the results for reactivity and solubility was not. It is not. Magnetivity not. And the density. So we calculated a mass of 31.36 grams and a volume of 4.33 cubic centimeters. And this results in a density of 7.24. So now we go to the density table. So looking at a density table, we find that the expected density of tin is 7.28. So using that as our starting point, we're now going to apply the results of the other tests, because 7.24 is pretty close to 7.28. And if we apply the other things to it, we're going to find that tin is not soluble in water, tin is not reactive with water, tin is not magnetic. So the last step in this conclusion phase is to compare our sample to known examples of tin. And if you have a sample display where all kinds of different metals or elements or minerals, you can take your sample and go compare it to those. Or you could go to Google and say pictures of tin, since we think it's tin, and we could compare our sample to the sample images that come up. So that's it. That's our analytics virtual lab, where we do the testing in order to come up with something that we can compare to a known, and then we were going to back up and make sure that the density that we found for tin, which ours was close, do the other characteristics also match tin? We don't know if 100% sure that this is tin. What we can conclude is that it has the same density, magnetism, solubility, and reactivity as tin, and it matches the visual appearance of known samples of tin. So we can make that claim. There are more sophisticated lab tests where we could find out what it does react with and in what combinations, and go from there. But for a introductory lab on analytics, or whatever you want to call this, there it is. So there's the results. Hopefully you enjoyed the video. If you did the virtual lab, you're not even seeing this. You stopped back there at the results page. But if you're just watching the video, thanks for watching. Sign up for notifications, comments, questions, all that stuff that you do on YouTube videos. See you in the next episode.